This is an introductory lecture on matrices for Math 107, Chapter 5. A matrix is simply a grid of numbers. In business, the grid has special meaning, but once you write the matrix, all those descriptive words are lost. For example, the matrix might mean the number of products, the cost for the number of products at several store locations. But the fact that it's certain products in certain locations, that gets lost when you write the matrix. What you gain, though, is this grid of numbers is that you can put this in a computer or a calculator and use the computer or the calculator to do many calculations on the matrix. But you do have to remember what went in which column and which row. Right, the columns are vertical, and the rows are horizontal. This is standard terminology. It's used in databases too. So this matrix right here, this is row 1. Here's row 2. Here's row 3. And the bottom one is row 4. That's everything in this row. Right. Now the columns, column 1 starts here, column 2 is here, and column 3 is over here. The elements, those are the numbers that go into the matrix, have to be tagged by their location, by their row and column number. And that's done in general by writing A, signifying some number, I, J. The I is the row number, and the J is the column number. So A11 is the element that's in row 1, column 1. Well, here's row 1, here's column 1, and you can see A11 right there. A41 is the element in row 4, here's row 4, and column 1, and you can see A41 right in that space there. The reason that I and J are used is because it's customary in math to use the lowercase letters in the middle of the alphabet. It's I, J, K, sometimes L. You try not to use L too much. M, N, and then you don't use O, but you might use P. Use these letters in this group as counters. In this case, they're counting the rows and counting the columns. In Fortran, the computer programming language Fortran, those letters, not P, but the other letters were considered to be integers. They were sort of forced to be counting numbers, and if you didn't want them to be counting numbers, you had to redefine them. In C and C++, these numbers aren't specifically set aside. You have to define them in your code. When we talk about matrices, we usually don't care that it has 12 elements or 20 elements. We care how those elements are arranged. So when we refer to a matrix, we usually give the matrix and the order. It's called the order right with it. The order is the number of rows and the number of columns. And it's written like this. Well, in this case, it would be a 4, and you would say 4 by 3. A 4 by 3 matrix. Now, 4 by 3 matrix has 12 elements, but it's very different from a matrix that, say, has 6 rows and 2 columns. That would also have 12 elements, but how it's used mathematically is very different. So you specify the number of rows by the number of columns. That's called the order, but often we call it the size. Technically, that's wrong, but it's done commonly. There are many special matrices. The two that you need for this class are the square matrix. A square matrix has the same number of rows as columns. Here's a 4 by 4 square matrix. 4 rows and 4 columns. The identity matrix is a special case of the square matrix. In an identity matrix, there are 1s right along the diagonal and 0s every place else. So here's a 4 by 4 identity matrix. The 3 by 3 identity matrix would look like this. So this would be 3 by 3. So we've got 3 rows, 3 columns. You can see right down the diagonal you'll have 1s and 0s everywhere else. Of course, now that we have matrices, we want to do arithmetic with them. And one of the first things you want to do is say, are two matrices equal? They're equal when they have the same number of rows, the same number of columns, and all of the elements in each row column little grid are equal. So if I've got a 2 by 2, say, and I have 2, 4, 6, 8, this is equal to only another 2 by 2 matrix, 2, 4, 6, 8. Okay? And if this is matrix A and this is matrix B, we could say its entries are A11, A12, row 1, column 2, row 2, column 1, and A22. And this one, if I say its entries are B, be B11, B12, B21, B22. What I require is that A11 and B11 are the same, or A22 and B22 have to be the same, or A12 and B12 have to be the same, and similarly with A21 and B21. That's abbreviated this way. You say that Aij has to equal Bij for all ij in the matrix. So when A has a certain value, it will appear both as a leading term here in the subscripts that will appear as a row number, and then J will always be the column number. The first is an example of a matrix that's equal. It has, this is a 3 by 3, this is also a 3 by 3. You can see that all the elements are identical. Now look at the second one. It has the same element values, 1, 2, 3, 4, 5, 6, 7, 8, so it's using, very interesting, I really don't know what happened to 4. Okay, 10, 11. Now you can see that all the elements have the same value. However, they aren't arranged in the same way. This is a 3 by 4 matrix, 3 rows and 4 columns. This is a 4 by 3 matrix, and these aren't equal. They aren't called equal. You would not say if this is matrix A and this is matrix B, in this case A is not equal to B. Sometimes this inequality gives you some equations, and this is, I believe, in the test, or maybe it's in the homework. If we say that these following matrices are equal, well, first you'd have to say, do they have the same number of rows and columns? The first one is a 3 by 3, and the second one is a 3 by 3, so this is making sense. And if they are equal, then this x has to be 3. That's what I've written here. The 1 and the 1 are the same, the 0 and 0 are the same. Okay, 0 and 0 match up, but here I have a variable y. It has to equal whatever is in this, in the 2, 2 place in the second matrix. So y2, and here's the z. This is in the second row, third column. So z has to be 3. Now I have a variable w. It has to equal whatever's in the in row 3, column 1 place. So w better be 4, and of course the 2's are matching up, and so are the 1's. So that's basically it on the introduction. Mainly there's a lot of vocabulary. A matrix, it's a grid of numbers. That's just a grid. The order of the matrix is the number of rows by the number of columns. For example, a 2 by 6 matrix has 2 rows, 6 columns. The elements, okay, the elements you denote by some lowercase letter. Usually if you have matrix A, you denote the elements by lowercase ij. If you have matrixes capital B, and then the elements are Bij. Okay, the elements, I'm writing up here, Aij, where I is the row number and J is the column number. This gives a little address where you can put that value. A square matrix has the same number of rows as columns. Number of columns. Okay. The identity matrix is a square matrix, but it has 1's on the diagonal and 0's everywhere else. Zeros elsewhere. And equal matrices, they're equal if they have the same number of rows, the same number of columns, and in each grid, each element, cell of the matrix, the values are equal.